Good day everyone! Welcome to Math with Teacher Justin. On today's topic, we're going to talk about rationalizing the denominator with one term. One of the rules for simplifying radicals is we are not allowed to have a fraction as our radicand, and we are not allowed to have a radical expression in our denominator. So here are the steps in order for us to rationalize our denominator.
Okay, so here are the steps in rationalizing the denominator with one term. Step 1. Multiplying the numerator and the denominator by a radical expression that will eliminate the radical in the denominator. Step 2. Simplify all radical expression. Step 3. Reduce the resulting fraction to simplest form, if possible. Let's proceed to our example. Alright. Okay, so let's have an example. For example, we have 4 over square root of 7. So in this case, we're going to rationalize this. So we need to multiply the numerator and the denominator by a value that will make our denominator whole number. So in this case, imagine that our index is 2 and our exponent is 1. So what do we need to multiply to 7 in order for it to have a value that is equal to the index? So we're going to multiply it by the square root of 7. Okay, so we apply the product rule. 7 times 7, that is 7 squared. So if we're going to multiply our denominator by square root of 7, we will also multiply the numerator by square root of 7. So let's simplify. Apply the rules in multiplying radicals and multiplying fractions. So let's multiply 4 times square root of 7. We have 4 square root of 7. Square root of 7 times square root of 7, we will have square root of 49. Now let's simplify. So for square root of 7 over, what's the square root of 49? That is 7. Therefore, we will have this. Now, question, can we cancel out 7 and 7? No, because 7 is not inside the radical symbol, so we cannot apply dividing radicals. So our final answer will be 4 square root of 7 over 7. Alright. Okay, let's have another example. For example, we have a square root of 2 all over square root of 5. Now, in this case, we cannot simplify our radicand. We cannot simplify our radical. So we're going to rationalize this by multiplying the numerator and the denominator to a value of the denominator that will make it not radical. So in this case, we're going to multiply our numerator and the denominator by the square root of 5. Okay? And square root of 5. Okay? Then, apply the rules in multiplying radicals. So we will have square root of 10 over square root of 25. Now let's simplify this. We will have square root of 10 over 5. Now, can we simplify this? Again, please do not cancel out 10 and 5 because they are not the same. Okay? Because 5 is not inside the radical symbol. And also 10 is not outside the radical symbol. Therefore, this will be our final answer. Ayan. So let's have another example. For example, we have 12 over the cube root of x. So we're going to multiply our numerator and the denominator by the value that will make our denominator not radical. So in this case, we're just going to think of a number that will make our radical be equal to our index so that we can cancel out our radical symbol. How many x do we need in order for this to be x raised to 3? So it is x squared. So we're going to multiply our numerator and our denominator by the cube root of x squared, so that when we multiply this will be, the radical symbol will be eliminated. So since we are going to multiply our denominator by the cube root of x squared, we are also going to multiply our numerator by the cube root of x squared. Then let's perform multiplication of radical. Okay, so let's multiply. And so we will have 12 cube root of x squared all over the cube root of x cubed, applying the product rule. So, simplifying this, we will have 12 cube root of x squared all over x. So, our final answer will be 12 cube root of x squared all over x. Okay, let's have our last example for today. So, for example, we have 19 over the fifth root of 4. Knowing that we have a composite radicand, we can just simply factor our radicand. So, convert lang natin. Let's convert it to our factored form. So, the fifth root of 2 squared. So, I just converted it to factored form. Okay, to its exponential factored form. Okay, so now we're going to multiply our numerator and the denominator to a value that will make our denominator not radical. So in this case, we're going to have the fifth root of, fifth root of, so how many 2's do we need in order for this to be equal to 5? So we have 2 raised to 3. So 3 plus 2, it should be equal to 5. So since we are going to multiply our denominator by the fifth root of 2 raised to 3, we're also going to multiply our numerator by 2 raised to 3. Okay, so let's apply the rules in multiplying radicals. So in this case, our numerator will be equal to 9 fifth root of 2 raised to 3, and our denominator will be the fifth root of 2 raised to 5. Now, simplifying this, we will have 19 times the fifth root of 2 raised to 3 all over 2. And then, we can now also expand this. That will be equal to 19 times the fifth root of 8 all over 2. And since we cannot simplify 19 and 2, that will be our final answer. Okay.
Now that you already know how to rationalize the denominator with one term, it's your turn to try it. Please click the link in our description box below in order for you to test your skill. Again, I'm Teacher Justin. That's it for today. Goodbye, God bless, and stay safe. See you on my next video.